Alright, in this video we are going to look at logic gates. So computers are made up of thousands of these things called transistors. These are switches in the computer that are used to represent signals. In easier words, transistors are used to represent those binary numbers that computers understand. In fact, transistors are the reason computers only understand binary. Think about it this way. A switch can only have two states, on or off. Or in a computer, it's 1 or 0. So, you know what a transistor is. But how about logic gates? Formerly they're known as Boolean logic gates. They are made up from transistors and are used to perform logical decisions within the computer. Logic gates take inputs and produce an output. Their output is all depending on what their rule is. Each logic gate has its own rule, and in this video, we're going to focus on just 3 logic gates for now. So the first one we're going to look at is an AND gate. An AND gate takes 2 inputs and produces 1 output. The rule here is simple. Both inputs need to be true, on or 1, in order for the output to be true, on or 1. This means if just one of the inputs is false or 0, the output will be false, off or 0. This is the logic gate diagram symbol for an AND gate. You can see the 2 inputs marked A and B, along with the output marked C. We can write this as a formula as well, with A and B equals C. Here's a truth table. In a truth table, we list all the possible inputs so we can show all possible outcomes. To write the inputs, you start with 0 in all input columns, then use all columns to write binary numbers in order, starting from 0. You should stop when all inputs are 1. In this truth table, you can see we only get a 1 when both input for A and B are 1. Here's an OR gate now. OR gates take 2 inputs and they produce just 1 output. The rule here is also just as simple. At least 1 input needs to be true in order for the output to be true. This means if just one or both of these inputs is true, the output will be true. This is the logic gate diagram symbol for an OR gate. You can see the 2 inputs marked A and B, along with the output marked C. We can also write this as a formula with A or B equals C. Here's the truth table. So as I said before, in a truth table, we list all the possible inputs so we can show all the possible outcomes. To write the inputs, you start with 0 in all input columns, then use all columns to write binary numbers in order from 0. You should stop when all the inputs are 1. Here you can see we get a 1 every time at least one input is a 1. When both inputs are 1, we also get a 1, as the condition is at least one input should be true. Now we've got a NOT gate. Now NOT gates take only 1 input and they produce only 1 output. The rule here is also simple. A NOT gate's output is the opposite of the input. So if we get a true input, our output will be false. And if we get a false input, our output will be true. This is the logic gate diagram symbol for a NOT gate. You can see it only has 1 input, which is A, and 1 output, which is B. And we can write this as a formula with NOT A equals B. Here's the truth table for the NOT gate. This one is shorter than the others, and this is just simply because it only has one input. And that is everything you need to know about logic gates for now.